Let's break down the process of how I created these meteor effects. First, let's see the render passes here. I created the Earth, just a Photoshop image, and apply this texture to a plane inside Houdini and render with camera shake. The next effect is the meteor itself. It's just a rock created procedural entirely in Houdini using Redshift displacement shaders to add these small details. This layer is just a gas leak from the edges to make this cool effect in the final rendering. Let's check this. This effect here, like a gas release in the edges, to make the look more dangerous, more atmospheric. The other pass here. Medium debris emitted from the main meteor. Render with camera shake too. And I create another pass here, the small debris. Fast moving debris emitted from the medium debris. The other pass that I create here is just sparks emitted from the meteor itself. Just 5 layers of effects that I created to compositing the shot. Let's dive inside in my Houdini project and see how I created each effect, each layer of effect. Here's my Houdini file. Let's dive inside the meteor setup and see the final result is here. Let's dive inside each node and see how I constructed the meteor. This is just a small geometry, procedural geometry created here in Houdini. Within spin, some rotation. Let's see from the beginning here, the network. First I create a sphere with a high division. I create a mountain. Then I scatter some points at this mountain here and copy to point some spheres, another small spheres with mountain, with some randomization in P-scale and orient. If I disable this, you can see all the small spheres are aligned and in the same scale. When I enable the P-scale, some interesting difference here, and when I enable the orient, you can see the randomization of the orient. And then I merge this back to the main geometry here. I convert this to VDB surface, and I smooth a little bit the edges and the facets, and I convert back this to geometry, high density geometry, just for create some scatter another points here, another amount of points like 32, and I copy to point some another spheres here with randomization in the P-scale, without P-scale, with P-scale. Then I create another mountain to displace the geometry to the normals of each sphere. I convert back this to VDB surface, just to make a subtraction from this, the main meteor, the main shape, and I make a subtraction here in the VDB using VDB combine. Then I use VDB smooth just to smooth the edges and inside. You can see here. I use a VDB resample just to... Actually, this VDB resample is doing nothing. And I convert back again to geometry, a high density geometry. Scatter more points. A lot of points right now, 200 points. And I copy again some spheres with the randomization, the p-scale, without p-scale, with p-scale. Convert this to VDB again, and create another subtraction, like creating like this cheese, surface. And I use a VDB resample to make the resolution down. And I convert back this to geometry. Actually, this is a geometry, high density geometry. And make another mountain here, just to displace the geometry and make more interesting details. I convert back this to VDB. And I smooth a little bit the VDB to smooth the edges, the connections, and just to convert back this to geometry. There are some attributes here we don't need, like the surface. We don't need this name surface attributes. And I create a mask, a noise mask, just to apply the displacement in the redshift. I create a mask here, fractal noise. This rest node is created just to avoid the sliding of the displacement shade in the redshift. And I promote these attributes, these rest attributes from point to vertex. And I save this geometry to avoid the processing of the entire network here. Then I rotate a little bit to initial rotation and adjust the scale. Then I animate the rotation using an expression here, controlled by this null control here. Spin in X is half of velocity, spin in Y is double of the velocity. Then in play you can see the rotation of the meteor, it's just linear. I use this trail here just to compute velocity, compute vel. And I create this name attribute just to reference inside the Solaris to apply the shaders, and just color all just for previews in the viewport. Okay. That's the result of the meteor. And right now you're going to see how I construct the camera shake. The camera shake, I call it the plugin from Houdini, the nodes from Houdini, call it the QLib. You can create a camera rig KL. This camera rig enable me to create a camera shake. Let's visualize the meteor here and see the camera, what's happening in the camera. That's the result of the camera shake. I use a camera rig using my camera here, and I create the channel network to apply the noise on the camera movements using this position and look at, and applying in the position some camera shake here. In the look at, I apply a camera shake as well. If you disconnect here, you can see the camera itself, there's no shaking. If I add the camera shake in the position here, you can see in the position some camera shake. And the look at, I can see the camera shake as well. For the creation of the earth background, I just create a small grid here, align this grid and animate it, and position this grid in regards to the camera viewport. Just a simple grid with the texture. This texture is created with collage in Photoshop. And that's the result of the camera shake with the background earth. Now let's dive inside the creation of some effects layers here. After the meteor, I created this medium debris setup. That's the result of the debris. Just a sphere with mountain emitted from the meteor in direction of the camera. Let's dive inside the setup. Just import the meteor here, convert this to surface, and I cache that, the surface, just to make the surface rotate. I just clamp the frame range. The frame range from the shot is just from 1 to 150. Just 5 seconds of animation. And I scatter points in the fog density. And create initially an attribute randomization in the orient. Just to make a particle emitter from this point here. Let's see the result of the caching, the particle emitter. From the camera view. That's the result of the particle emitter from the camera view. And let's see in the side view. Just simple particle emitter. Inside the PopNet, I just create the pop source itself. It's already created in the pop. Pop spin just to make the points rotate by some orientation defined here. This orientation is a random, and when I put inside the pop network, the points spin itself by some direction. And create a pop force. A little bit is pop force, just to make some noise movement in the particles. Before the cache, I just delete some groups. We don't need any groups, and we just need to keep some attributes like ID and orient. And I cache that. I clip the trail because I don't need so many particles behind the camera. For example, the camera I think is around here. We don't need the particles back to the camera, then I clip that. Clip the trail. And here, I use Vex script here, just to expand the particles emitter, like a cone shape. That's the script here. Let's increase the size. That's the script to adjust the cone shape, without cone shape, with cone shape. And I create a randomization DP scale by ID. And I retime a little bit just to scale the velocity. Here, just a simple sphere with mountain. And that's the result. Some spheres are scale stretched to make the illusion of the different fragments. And I compute the velocity here, just to make the motion blur in the rendering. Actually, this here is just for visualization in the viewport, because in Solaris we are going to send these points, just the points. We are going to instance the points with some small spheres with a random mountain. Use that points to make the instance. Here just for preview in viewport, and here we're going to send to Solaris, to Redshift. Let's dive inside these small spheres trail setup here. The result from the camera, just a lot of points emitted from the medium debris, make like a rain. These chaotic trails here from 80 debris. Let's see what is happening in this network here. I just imported the medium debris and I assemble that just to extract each point, each centroid point for the debris. And I create an attribute here just to make the parent, which point is parent to each point in the debris here. And I delete all the attributes we don't need and keep the parent ID, creating this Vex here. Inside the pop network, the result of the caching is here. Just a single point by each of the one medium particles. Inside the pop trail, we're going to use the pop force just to make the random noise, and pop color just for fading, to create alpha fading. That's the result. Here there's interesting stuff because we are slowing down here. Let's cache again this. Now it's correct. And I create a lines for each trail using this parity ID to create a line for each group of the points. And I resample these points, convert to the subdivision curves just to make it smoother. And I use the polyframe to see the direction of the velocity here. And I carve some points here because we don't need so long lines here. The lines should be shorter. And I create a sweep just to make small tubes for each line. And create again another pop network with this result here, emitting particles from the sweep geometry here inside the pop network. Just in creating emitting points from each tube using pop force. And the result of the point simulation is this. Let's see in the camera. Just like a array of points. I create the particle randomization here, particle by alpha, but we don't need the density. The density we don't need here. We can remove because we're not going to use this node. This node of rasterization VDBs here. Delete attributes we don't need and keep the ID and the velocity. Create a randomization in p-scale and a randomization in orient. Just to instance a little small spheres with noise inside the Solaris. And these nodes we will send to the Solaris to render. Now let's dive inside the Spark setup. It's just a simple setup. The result is this. Just small lines here with the color, gradient color by the extension of the line. Let's see how I created that. Just import the meteor here, animate the meteor, and clamp the start and end frame here, and create a particle simulation. Let's dive inside the particle simulation to see what is happening here. Just another pop force with pop drag to avoid the high scale velocity. Emitted from the surface of the meteor. That's the result of the particle sparks. These nodes here are just used to remove the attributes we don't need for caching. Then I compute the velocity just to using the rendering to make the motion blur. And I just adjust the color to make some randomization in the color and create a particle tray here to make each point like with the trail width. And I resample these nodes here just to each few points per line. The last effects we create is just these gas leak edges. Let's dive inside and see the result. The gas leak is just a volume emitted from the, actually just particle emitted from the edges of the meteor and convert back to the density, VDB density. Let's see how I create that. First, I import back the meteor and I convert back this to VDB surface, convert back to the geometry just to make a small resolution here, and I use this labs node here just to extract the silhouette. We just want the silhouette, emitting particle from the silhouette, and delete attributes we don't need. The result of the cache is here. Just the silhouette, animated the silhouette from the meteor. And I poly extrude that. Just add a peak to like move the geometry by normals. Create another, extract the silhouette. That's the original silhouette. And that's the new silhouette. And I sort this just by vertex order because we are going to recreate the connected lines here. And I resample this. Just to avoid the incorrect space here. And I resample just to maintain the space. And I create this noise color here. Just to make like an animated noise fractal the colors. The red areas here, we are going to scatter points. That's the result here of the cache particles edge leak. That's the result. Let's see in play. Like a fast moving particles, let's see from the camera. A fast moving particles from the edges. The red areas of that spline. Inside the particle scene, just another pop force with amplitude based on some random values, and a pop Q because we don't need so many particles after the X max here. If you see here, you just emitting particles until the 15. We don't need particles behind the camera, and I use that pop Q just to clamp the particles, kill the particles after the 15. After the 15 here, 15 measure distance. I scale this in X just to stretch. And I use the FX script here just to expand the edges, like make a cone shape instead just a linear. I create a cone shape. Let's see in the camera. Like this. Delete the group we don't need. Compute velocity using ID. And create some randomization in the P scale and in density. In this script we are going to use density because these particles will be converted in VDB fog. I create a clip here. Because we don't need these particles behind the camera, you can save some space in the cache. Convert this to volume rasterize. And save the caches. That's the result. Let's see the camera. That's the result of the visualization. And this node is going to send to the Solaris to render. These nodes here, just for transforming a line to the camera and the regards of the meteor. Let's see the visualize here. Just to adjust from the camera, some rotation. The meteor, the medium debris, small debris, sparks, and gas leak. This is just a transform to align it to the camera view. Inside of these nodes, there's a reference. These nodes we are going to send to Solaris because there are some transformation here to align it to the viewport. Let's dive inside the Solaris and see how I constructed each layer. First, let's see the Earth background. I just import the Earth background, the plane. Here, I use the render geometry setting just to enable the velocity blur, because in the camera shaker there's some velocity blur. Even if the plane is stopped, we need to create these nodes to apply the camera shake motion blur. Let's see from the camera here. And the material that I create. Just simple material, Redshift material. with the diffuse. Let's see what is happening. Let's see the text right here. Just that image here. And apply the shader. This node here, camera motion blur, just a cache node to enable the motion blur for the camera shake. This scene import camera, we are going to import that camera. We are creating the SOPs, the camera render. We are going to use in SOPs instead of create a new camera inside the Solaris here. And that's the Redshift node. For the rendering, let's see the rendering here. Just one frame. That's the result of earth background. Now let's see the sparks. I just imported the sparks here. Using the render geometry settings just to enable the velocity blur. Create just a redshift sparks here. We are going to grab just the color of the particles instead of using CD here, the native CD from the Houdini. We need to import the display color with the capital C, just to grab the color and apply to the line. Assign the material to the curve, the lines. Import our camera using another cache for motion blur and create a redshift render here. Let's see from the camera and let's see the resulting redshift with the motion blur. The render of each frame is pretty fast, just aligns with color and some motion blurs. Let's see here. Now the meteor, but let's dive inside this complex network here and see what is happening. First, we import the meteor. Then I create an instancer for create the small debris and create some debris here, just a sphere with mountain. Using this instance here, I just grab the reference of the points and use the instance just to instance a small sphere with noise for each particle here. The same stuff in the medium debris. I just create a sphere with a mountain and use an instancer to instance one sphere per point, using the P scale and the orient to make the direction and the rotation of each debris. And we need to create this render geometry settings here just to enable the motion blur too. The last effect pass is gas leak, just that the volumetric trail. I just adjust the transform here just to align it to the camera, just a little bit of rotation. I merge all these nodes here, but we are not going to render all the passes in the same render. We are going to split here, but we are going to apply the shaders to all the passes at once. Here we are going to use velocity blur. We are not using this collection anymore. We can disable that. I create few materials here. Meteor material, medium debris, small debris, and gas release. Let's see first the result of the meteor and dive inside the redshift shader to see what is happening. But first let's see in the viewport what is happening in the meteor. That's the result of the displacement shader. Let's dive inside the shader and see how the shader is structured. Meteor. First, for the color, let's disable the displacement first and see what is happening in the color. Without the displacement, the meteor aspect is looking horrible. It's looking terrible. There's a lot of roughness here, but the looking is not good. Let's disable the velocity. Okay, disable the velocity here, just to see the look of the meteor. Okay, disable here, motion blur. Can disable motion blur here. And disable the camera cache blur. Let's see just the aspect of the meteor. Let's increase the sample here just to make faster rendering the viewport. That's the maximum noise applied to the color. There's nothing so great here, but just to make some variation here. The trick here is create another maximum noise to apply in the displacement. Let's see just the displacement without any color. I create a maximum noise using type FBM with octaves and some scale here, and I multiply by some value here. These nodes were not in use because I tested some values in the add vector. We don't need this node. And I use that mask in the meteor just to apply the intensity of the displays for some areas more intense and another areas less intense. And I create this displacement node and apply to this displacement here. Let's see the result. Actually, we need to enable this node here because here we are using the tessellation, enable tessellation and enable displacement for all the objects, except the gas release. Gas release don't need the displacement. That's the look of the meteor with the displacement. Let's apply the color and see the result. That's the look of the meteor, like a gigantic popcorn with displacement. Let's see the camera from the camera view. And now we are going to see the medium debris, the result, and how the shaders was structured. The medium debris is just like stencil. The shader, let's look at the result in the viewport, the rendering. Here we have the motion blur, camera motion blur here. We need to enable the camera blur. The motion blur is already activated. In the shader, the medium debris. The medium debris is using the same shader from the meteor. There's no difference. Actually, the difference just here. We are not using that mask in the calculation of the shader. We're using the same FBM maximum noise and the same displacement turbulence color in the surface. Now let's see the small debris. For the small debris, we don't need, because the particles are so small, the instances are so small, we don't need any displacement. Actually, we don't need any shader applied, but let's see what is happening in the shader here. Actually, I'm using the maximum noise, but the size is so small you can see any difference if we have displacement or not. Using maximum noise in the color and the displacement, but the displacement is actually we are not using the displacement, we are using the bump map, but I think the difference is so small that won't make any difference to use the bump map or displacement. The final pass layer here, the final layer of the render is just gas release. Let's see the result of gas release. The shader is pretty simple. Gas release, just a standard volume with some values here. Because actually we don't need any temperature, we don't need any the emission values, just the density, natural density. And that's the result of the gas release. Here is the result of the compositing in Nuke. Let's see the play. And let's see each color correction separated. Actually, the time frame is just 150. That's the result of compositing. Now let's dive inside of it pass. Here just the earth. And I import the gas release before the meteor. Make some color correction here to make it more bluish and merge with the earth. Import the meteor. Merge with the last layer, the gas release in earth. Import the medium debris. Merge to the main layer. And merge to the main comp. Import the small debris here. And merge to the main comp. I import the sparks. Make some color correction here. Make some glow. And merge back to the main comp. I'm using a LUT here just to make the color grade more greenish tone. Create another color correction to make it more bluish. Add the color grade to decrease the black and increase the whites. Create another color grade to increase a little bit the whites. Create a constant here in the radio to make the vignette and multiply with the main comp. And I apply some noise grain here just to make more cinematic. And that's the result of the rendering. Thank you guys. If you want to buy this file, you can access the link in the description. The file is available at Gumroad. Thank you guys. See you in my next tutorial.